If you ask a person who has completed the whole concept of physics that which is the hardest problem to solve, he will answer you that it is friction, question number 28. Yes guys, the concepts of physics is divided into two volumes, part 1 and part 2, but our problem belongs to part 1. So the question is from chapter 6, friction, question number 28. Actually it is the advanced version of question number 27, in which the friction coefficients are involved to make things harder to calculate. So we will try our best to solve the question. The question is as follows. A block of mass small m slips on a rough horizontal block of mass capital M under the action of horizontal force applied to it. The coefficient of friction between the block and the bigger block is mu1 and that of the bigger block and the ground is mu2. Find the acceleration of the bigger block of mass capital M. So let's figure out how to solve this problem. First we will know how many forces are involved here. First is the gravitational force, second is the normal force in opposite of gravitational force, and due to normal force a frictional force also acts in the perpendicular direction, and since there is pulley involved there must be tension in the string. So first we make the free body diagram. So first we imagine the acceleration A which capital M suffers. So if the bigger block moves the distance x, then since there are two strings directly in contact of the small m, so it will move a distance 2x. So if the capital M moves with the acceleration A, then the smaller block will move with the acceleration 2a. So we make the free body diagram. So first we make the free body diagram of smaller block. First we consider the y coordinates. There is gravity downwards m times g, so there will be a tension in the string T, and since the bigger block is moving with a force m times a, there will be a normal force opposite to it n1, so there will be friction mu1 n1, and the normal acceleration which we have discussed that the acceleration was 2a, so multiplied by mass gives us 2ma. So we end up with the equation n1 equal to small m times a, and the second equation mu1 n1 plus t plus 2ma equal to mg. So we will solve for the tension and get this. Now we will find the free body diagram of capital M. First we consider the y coordinates. There is gravity, so capital Mg downwards. Due there the pulley is attached to the bigger block, there will be a tension T downwards, and since the smaller block is applying friction to the bigger block, so there will be a force mu1 n1. So let's find the x coordinate. Since there are two strings attached to the bigger block, actually a pulley and a string, there will be a tension 2T right in the right direction, and since a normal force is acting upwards, so there will be a force, so there will be a frictional force mu2 n2 leftward in the left direction, and since the block is moving, so of course there will be acceleration. So of course there will be a force ma in the left direction, and since the block is lying on the bigger block, so the normal force will generate a pseudo force n1 in the left direction. So writing the equation give us this. Now solving for normal force of bigger block, since we derived the formula for tension earlier, gives us this. Now inserting the values of n2 and t and n1 gives us the equation this. Now we shift the variables to one side to get our answer. So this is the final answer. The acceleration is a big term multiplied by the gravitational acceleration. So here is our answer. If you like the video, then subscribe to the channel and share the video to your friends so that the hard problems will start appearing easy. Bye.